It is organized by TCE department, and in the same workshop I met Mr. Shimoga sir. How many of you met him? He was secretary of the NEC this thing, and I had a very short discussion with him about he was a strong believer of Gandhian philosophy, and I had a discussion on truth and national interest with him. That was a very strong discussion. I still remember that discussion, and I had become his fan after that discussion. That is my connection with JNNCE. And why I am saying this is because truth will not rise if you are interested in something. It is always be biased, whether it is a national or personal. Real truth is always unbiased. That was my argument. Like, he convinced me. That was a philosophical discussion. I will not go in depth, but like that was my connection with the JNNCE, and I am always thankful for him and JNNCE for that opportunity. Right? I just wanted to share this thing. And today, as Professor said, my expertise lies in ARM processor. Since from 2011, I have been associated with ARM, and I am handling these workshops. It is actually a 2-day workshop, a hands-on session, and I have done 25 workshops till now and trained 990 students and faculties together. So that is how I got the link for this program also. And but when I came here, like, it was cloud computing and big data analysis. So I was thinking how to relate my topic of discussion to your topic of the day. So I just wanted to know before, well in hand, that like how many of you are faculties from the computer science background? Faculties from the computer science background. Right. How many of you are the faculties? Okay. How many of you are the faculties from other backgrounds? Right. That's good. How many of you are the students of the computer science branch? All of you. Okay, non-computer science? Non-computer science branch? Nobody. So the crowd, I have to believe that like all of you are from the computer science background. Which semester? Which year? 6th semester? 6th and 8th combined? MTech. Some of you are MTech. So above 6th semester, right? So have you studied any processor or microcontroller in your syllabus? Any processor? 8086. All of you have studied 8086. Who has not studied 8086? All of you have studied 8086. Then you must have understood what Shantaram sir was saying. He got a computer in 1990s with 386 processor. 8086, 186, 286, 386. Then like 486, 586 has become Pentium series. Pentium 1, 2, 3, 4. Then like they have launched the I series. This is an Intel processor. Similar to that, there is an ARM processor. Okay, let me start like this. How many of you are interested that like, or give me a suggestion that like I should start with ARM processor and link that to the cloud, or like I should start with the cloud and then link with ARM processor? How many of you for first choice? I should start with ARM processor and link with cloud. I am doing a small project on the cloud related thing. I will only be able to speak on that, not brief or like complete in depth about the cloud. My knowledge in that is very, very limited. Let me be very frank. So whatever the project I am doing, I will start with that. Right? Otherwise, I will start with the normal procedure. Like I will start with what is embedded system, processor, then like why ARM, and then like I will try to explain my project at the end. What is your choice? First project or then ARM? What is your choice? First? First I will start with project. Okay. Sir, is that that thing? Whatever I do, I am only the face which represents all the sensors. All my sensors are my students. They did every work, I am representing that work. Right? So everything that I speak today, it is all the student effort behind me. I am only representing that effort. Okay? Including the animation. Including the animation now. Now try to see this animation. I believe it is convincing. I believe it is convincing. If it is not convincing, I will explain. Yeah, all of you understood this? It is convincing? Yeah. Like when you are thirsty, you take water and drink. We are trying to create a system when the plant is also thirsty, like it drinks in water by itself. Because you have a sensor and actuators, you can move and take it. So plant does not have actuator, it has a sensor. It also feels thirsty, but it does not have actuator to move. Your leg is an actuator, hand is an actuator. Everything is an actuator which has to coordinate, right? So we are trying to make a system which does this job, okay? We did it to some extent, but scientifically there is still a lot of study to be done on this yet. And I have started this project in 2012. This has been the 4th year, but I have understood very little. Okay, there is a lot of things to be understood, especially when it is a interdisciplinary. Okay, I know what is my part of the job. Connecting to the understanding of the civil professor or the farmer or the professor from the agriculture university, their thinking method, like you guys in CS think very differently from the guys in the mechanical. Have you experienced this? Right? This comes by the involvement with our discipline. So understanding every aspect and requirement is very difficult. So I have tried something on that. The result of this, I will show you that now.
Ample research is being conducted in the areas of water, agriculture, energy. Sustainable engineering provides a greater amount of solutions. We at BMSCE embark on such kind of research activities. One of such great projects is a multidisciplinary one, sustainable agriculture. Basically in India, the land holding of a farmer varies from 0.25 or quarter acre to 50 plus acres. The smart irrigation system that is existed in the Western countries is very, very costly. So we cannot ask for a small farmer to adopt that. The yield of a crop depends on so many factors. One is water, the other one is soil. Field capacity is the maximum moisture holding capacity of the soil against gravity. Permanent wilting point is the point up to which a plant can extract water. Now, for optimum yield of a crop, my moisture should fluctuate between the field capacity and the readily available moisture. Now, in order to sense this moisture present in the soil, we have what is known as this soil sensors. This is ISI Class A pan. This gives the evaporation for a day or 24 hours. Basically, knowing the evaporation per day, one can determine in how many days the crop requires water. This is a weather station. This gives about 7 parameters: wind direction, wind velocity, relative humidity, solar radiation, temperature, rainfall. The values, whatever we are getting from this, is all integrated onto the control panel where analytical signals are converted into digital signals. To develop a robust system which is much more robust than the wired system, we formed a team called BMS Delta X team. Now, whatever the results we are getting from the wireless system, we compare those results with wired system.
So this is a wireless model that we have developed over the time.
What this does is like this collects sensors values from the field, and then like it sends the data to the user mobile and also to the internet. This is a power supply part that we have, which converts 12 volt to 5 volt, which is optimum for this board. And this has an sensor port to collect the values from the soil moisture sensors. This is an actuator part which will actuate the solenoid valve to make the water flow to the field or not to flow to the field. This has an RTC to monitor the timings at which the data is acquired. This has an optional USB wherein which if data is not transferred using any of the wireless module, the data can be collected from the pen drive through this USB port. This board is built around the central processing part using a ARM Cortex M3 board.
This algorithm is implemented on LabVIEW, which is a proprietary of National Instruments. Basically, this consists of soil and crop type, soil moisture, irrigation, then weather display, energy management, and water management. Algorithm looks for type of soil and the type of crop. Whatever the type of soils that are available in entire India, we have a repository of type of soils and also their characteristics. Right now, the soil what we have in the field is silty clay. For silty clay, the field capacity is 36% and the permanent wilting point is 21%. So the difference between these two will give you the available moisture. So suppose if I change silty clay to sandy soil, values automatically changes. In order to calculate the amount of water to be given to a crop at any given point of time, I need the depth of root zone. So in order to find the depth of root zone, I need the age of the crop. For this, rate of sowing is required. For optimum yield, moisture content always varies from field capacity to maximum allowable depletion. We have 4 sensors. Now this is the real-time data what we are right now getting. The question is why 4 sensors? Suppose if the root depth is within 15 centimeter, then the algorithm considers only the first sensor. Suppose if root depth is somewhere between 15 and 30 centimeter, then it will take the average of these two values, and that value of soil moisture is considered for calculating the amount of moisture required. The next frame is about irrigation. Right now, the root depth is at the 3rd sensor for calculating how much quantity of water required. So the algorithm takes all the 3 sensors. This frame gives about the weather parameters. We'll have the temperature versus time, then radiation versus time, then relative humidity versus time, rainfall versus time. So right now there is no rain, so that's why we are seeing 0 here. We do have what is known as solar radiation, temperature, wind direction, wind speed, and barometric pressure. We have 3 photovoltaics. Out of 3 photovoltaics, 2 photovoltaics are connected to the centrifugal pump, and one is connected to the submersible pump. This shows the amount of water flowing out from measuring time. So once the algorithm calculates the required quantity of water, solenoid valve automatically opens. We have water sensors placed inside the measuring tank. Once the required quantity of water comes out from the tank, automatically the solenoid valve shuts.
This is a part of the wireless system. We have designed a website kems.org, and this is the homepage of the website. If we click on this EMS tab, give the mobile number and the password of the user, then we'll go to this tab, in which it is exactly very similar to the wired system. We have to select the type of soil, and then we have to select the type of the crop. Let's say date of sowing is done in the November 1st. We are getting the sensor values. Sensor value 1 is this. Similarly, soil moisture sensor value 2 is this. So we also have the weather monitoring system, in which we are taking this weather information from AccuteWeather.com. We will also get the data onto the mobile, whether the plant needs a water or the pump is on or off. The final decision taken by algorithm is indicated to the user through the mobile. Had a lot of fun in working on this project with a lot of students. Around 20 plus students worked with me on this project.
This project gives me a lot of satisfaction because of so many reasons. I am from agriculture background. My father is a farmer. The aim of BMS Delta X team is to see the smile on a farmer's face at the end of the day. We are sincerely thankful to VTU and TechIF for sponsoring this project.